Hello, hi, welcome to my presentation about the project in the Code for Machine Learning. And the project is about to use the machine learning in application project. I need to choose a project topic and work through the series of steps to evaluate the opportunity and walk through the business understanding phase of CRISP DEEM process and develop a valuation plan for the solution. Consider key machine learning system design decisions and identify potential issues that may affect the model in production. Let's directly jump into it. So the problem that I have identified for the project is the card frauds. Today the card frauds are detected, but the recovery may or may not happen because they are just detection. They are not really prevention. So the problem we are trying to solve here is to able to prevent the fraud from happening in the first place. It's almost like a spam. That if you have a spam email, it is detected and you don't need to open the email and so forth. I have mapped the business impact and feasibility of the solution below. So it is somewhere here. In my opinion, it has a high business impact, but more close to towards a lower feasibility due to high volume transactions and action needed in milliseconds. Uh, the business understanding for this, if we will go by CRISP-DEEM process, we'll define the problem. The target user is the bank CEO. Problem is we need to predict in advance the transactions that can be fraudulent and we need to stop them. Why it matters? Because it can reduce the effort, money, and stress for the customers who can lose money. And the current state, I would say, is that we already have a card product, fraud products, which prevent the card frauds and alerts the users and business, but they do it too late. And it's also most of the time post transactions or after settlement. And our we need to basically aim to prevent the fraud and detect it earlier. The success for this is prevent frauds from happening. Outcome could be percentage of fraud detection before first fraudulent transaction. Output could be improve the false positive rate because the customer may be unhappy with lot of false positive. Targets could be percentage of fraud detected before first fraudulent transaction is completed, could be 90%, and false positive rate is less than 1%. Constraints could be prediction must happen before the transaction is cleared. The prediction must have happened before it is cleared. So domain expertise is gathered by interviewing the fraud prevention team and defining how to convert detection to prevention, and in which we will identify the key factors. And the key factors identified are the historical spending profile, which are deviation from the normal patterns are strong early indicators. Then geolocation history, transactions far from usual locations, average transaction amount, sudden high value transactions are suspicious. Some new issued cards are more targeted than the old cards. The validation plan, if you can see, is for the machine learning is that we already explained about the business understanding. Then we need to prepare the data from the transactional data that we have and also the merchant profiles. For example, there could be some certain merchant profiles which are more prone to create fraudster transactions. And then we'll model it and we can use, for example, a random forest or XGBoost decision trees in order to evaluate our decisions and take better decision next time in the next iteration and improve the model overall in that. For evaluation, we have the metrics for false positive rate, early detection rate, and also precision and recall. Deployment and reporting, we'll deploy the model into production, real-time decisioning, and approve, challenge, or decline. So it's of whatever decision is being taken by the model. Model output could be fraud risk score, whether approved, decline, or challenge, and business outcomes are early fraud detection rate, false positive rate, and fraud loss prevented should be low. Machine learning system design, we have the use case of our fraud prevention. So requirements are that it must respond less than 50 to 100 milliseconds per transaction because that's the authorization window in which transaction get authorized. then handle thousands of transactions per second because there is a huge volumes of transaction. It supports retraining, monitoring, and feature updates. And false positive must be minimized, and it must be possible to integrate with the existing authorizing, acquiring, and issuing systems. Then we have a system design for that because it is very it should learn all the data related to the new transactions happening. It should be on cloud, and online learning is needed, as well as online predictions are needed, and it needs to be trained with the batch training as well from data from various sources. The issues that can arise in the production are mainly data drift and concept drift. Data drift could be as the model is trained on the static training set, which changes over time, like geographic allocation, and changes the and change can happen like all of a sudden you can start getting transactions from internationally in the model. Froster changes the fault patterns. It needs to be retrained. The model needs to be retrained, and the results and changes of features can also happen because of that. Concept drift is also possible. User behavior and spending patterns can change. And Froster can change the tactics. For example, instead of doing high volume transaction, they can reduce the volumes and they can get to know what is the volume at which their transaction is considered as risky, and they reduce it and so forth. So here we complete our project presentation. Thank you very much. I hope you enjoyed. Bye-bye.